Hey, hello. Today I'm going to be walking through how to do fNIRS data preprocessing using an open source toolkit called NIRS KIT. Let me share my screen. Okay, so in order to run NIRS KIT, there are a couple of things that you'll need. The first one is MATLAB. Any version post 2012 will work. I always recommend just installing the latest version of MATLAB. You'll also need to download NIRS KIT and some related toolboxes. So let me go to my browser. So it's pretty easy to find and access all of these things. So I'm just going to Google NIRS KIT. It's going to provide me with a GitHub link to download it. I'll just download the zip file and then extract the files from the zip. And then you also need to download the SPM um, folder, which is also going to be available through a GitHub page. This is the NIRS SPM website, and then it will have links to the GitHub. You can also, it looks like, download the software from here, but it's the NIRS SPM software package that you're looking for. Once you have those things downloaded, the first thing that you're going to do is make sure that you have all of your data stored as SPM files. Um, you can also work in a couple other file formats, including SNRF, for example. So if you're working with SNRF files, you should also have Homer 3 downloaded. But I usually work in SPM files. So when I create my SPM files, they include a couple different files, including a channel configuration, channel order, your data, your conditions, which are also your events, and then finally your optode information. I really only work with these two files. I haven't explored the other ones as much, but what I do after I've gotten all of my SPM files for each person is I tend to resort them a little bit. So I'm going to put each of these people's converted data into a new folder and then also all of their multiple conditions files into a new folder. So if you look at the way I have my data organized, I have a data folder. This is from the converted data files. And then I also have a multiple conditions folder. And this is, of course, the multiple conditions file. And then I also recommend creating a couple more folders that you can use to export your data from NIRS KIT. So you're going to want a data prepared folder and definitely a data processed folder. And then depending on how you do your pre-processing, you might want some additional folders as well. So I will walk you guys through what I use each of these folders for. So once I'm ready to start working in NIRS KIT and I have all of my files ready and all of the software installed, I'm going to start by opening MATLAB on my computer, and I'm going to navigate to where I have the other software saved and installed. So I'm going to right click on the SPM folder and add that to my path and include the subfolders. And then I'm also going to right click on my NIRS KIT folder, and I'm going to add that to the path as well as the selected subfolders. And as I mentioned, if you are working with SNRF, now would also be the time to add Homer 3 to your path. Now what I'm going to do is I'm going to run NIRS KIT. And to do that, all I'm going to do is go into the type command window and type NIRS_KIT, and I'm going to press enter, and it's going to start running, and it's going to display the interface for me. For the research I'm working on, we're doing a task-based fNIRS study, so I'm going to start by clicking that option. And the first thing that you always have to do is prepare your data to be imported to NIRS KIT. If you skip this step, your data is not going to open. So that's very important. So my input path, I'm going to navigate to that folder where all of my data is. As I mentioned, I had originally created this data folder. I'm going to select that. My data type happens to be this number 9 one. It's a NIRS SPM data. It's raw. I haven't done any pre-processing to it. And then I'm going to select my, that's not the right folder. Here we go. I'm going to select my data prepared folder as the output path. Um, If you don't separate these into separate folders, what's going to happen is it's going to end up overwriting each of your files. So that's why I recommend doing separate folders because you don't want to lose your original data files. So now I'm going to click run and it's going to start converting my data. And all that this conversion does is put the file formats into a format that they can be opened within your NIRS KIT. Next, what I want to do is I want to actually take a look at my data and explore it a bit and just get familiar with what I'm looking at. So now I'm going to navigate to my converted data folder, or my prepared data folder, I suppose I should say. I'm going to add that. And then now what you're going to see is it's going to load in all of our subjects that we had just converted the data for. So the first thing that you should do, and this part takes some time and also some practice getting comfortable with, but you're going to want to go through person by person and look at their data channel by channel and do a signal quality check. So it seems like this person is going to be a good person to start with because this is not a good fNIRS channel. I can tell that right off the bat just by looking at the way that the data is visualized. I know this person has, this was our first subject, so we were troubleshooting here, but let's move to a different subject. So I can show you what a good data looks like before we get into a bad data. Let's see if I can find. Okay, this is a pretty good example, I would say, of a really nice data signal. So what we're looking at here is the hemoglobin concentrations. My data specifically includes a rest period, which is the first half of the data, and then a task period, which is the second half of the data. I know that because I've worked with it before. If you don't exactly know what data you're looking at, I can show you later in the video how to identify your events and the event markers. But really what you're looking for to decide if your data quality is good is you're going to want to look for these little oscillations in your data. So fNIRS data before you do any pre-processing is going to have some pretty strong influences of other physiological signals. That includes the heartbeat and that also includes respiration. So usually when you're looking at a great fNIRS signal, you can see these small oscillations, which are the person's heartbeats. And then you'll also see kind of these bigger waves, and those are the respiration periods. So if you can see both of those things in your signal, then you can be pretty confident that you're measuring what you want to measure. Now, of course, when you are working with a task, especially one that involves movement, that pattern is going to be much harder to identify because you might have some motion that's affecting your signal. And the signal is going to be more sporadic just due to the nature of them using their brain more. But in this case, you should still be able to identify at least heartbeat oscillations. So yeah, this is a great signal. Let's go back to our first subject who had some poor signals. So there are a couple things in fNIRS recordings that can cause poor data quality. The biggest things are just poor contact with the scalp. So hair can get in the way of that. The position of the cap and the optode on the head can also affect that. And then, of course, we know also that things such as skin tone, um, head morphology, all of these things can also affect the way that the optodes are interacting with the scalp. So when you come across the bad channel, what you're going to do is right click on that channel and you're going to mark it as an exceptional one. And what that does is it tells the NIRS kit that you don't really want to consider that channel in your future calculations. Um, so like I said, this person has a lot of bad channels. So if I was looking at them, I would go through and exclude all of these channels where I cannot see good signal quality, which might be most of these. Okay, here's a good channel. This one's bad, bad. That one's good. This one's bad. This one might be able to be fixed with some pre-processing. This one's bad, bad. This one's good, bad, bad. This one's good, bad, bad, bad. Excuse me, this one is good and this one is good. So this person only has 1, 2, 3, 4, 5, 6 out of 22 good channels. Of course, as a researcher, you have to make a decision about whether or not this person would be worthwhile to include in your overall sample size. As I mentioned, this was the first person we recorded data from for this specific study. So my guess is that the researcher who collected this data was just getting familiar with the device and the setup. But as we move through our data set, we should see that, most of our channels have much better signal quality, and you might only be excluding 1 or 2 per person. So I'm just quickly toggling through this person as a better example of someone with a good signal quality. But you can see, like, channel to channel, we're seeing really nice oscillations in our signal. We can see, okay, so this person has 1 bad channel, 2 bad channels. So this is a pretty standard person who's just going to have a few bad channels, but for the most part, we can see everything that we're interested in looking for. So if I was pre-processing this data set, I would go through and do that for every single person and make sure that I'm excluding the right channels. So the next thing that you can do in this specific interface is start exploring some of the pre-processing options that are built into this toolkit. People often ask, what's the right pre-processing configuration? And there's no clear-cut answer to that. The best thing that you can do is, number one, explore the options thoroughly with your data set, because the right options are going to be highly dependent on what you were recording, who you're recording from, things like that. And then number two, read the literature for similar studies, see what they report. I know in my experience, for the most part, people like to include motion correction and then a bandpass filter, which I'll show you guys. I know detrending is also very common, although I personally don't use that in my own data. And then NIRS Kit also gives you the option to write in your own pre-processing steps. So for instance, if you don't love either of these motion correction algorithms, you can import your own. If you have a filter method that's not displayed here that you would like to work with, you can mess with that too. So usually when I'm pre-processing my own data, the first thing that I do is start by just investigating these steps one at a time to see how they really affect my data. I tend to prefer to work with the TDDR motion correction algorithm. I did not really like the way the CBSI altered my data sets, but once again, that's worth exploring with every data set. So this specific interface is just showing us a preview. So I can apply anything and it's not going to actually alter my data set in any way. It's just giving me a visualization of what would happen if I did use it. So we're going to keep looking at the same subject that we just went through the channels for. So If this is your very first time working with fNIRS data, you might not even know what a motion artifact in the data looks like. This channel has a fantastic example. Basically, when you're looking for motion, what you're really looking for is sharp spikes in the data, and those usually correspond to the participant doing some sort of quick movement with their head that affects the readings. Here's another great example of something that could most likely be a motion artifact. You know, it's just a very sharp spike that doesn't really seem to follow the rest of the trend of the data. So what I like to do is just make sure that whatever I'm applying to the data isn't removing any effects that I'm interested in measuring. So I don't want it to correct much more than the huge motion spikes. If it's changing things besides those spikes, it might not be the best method for your data set. As I'm quickly flipping through this person, I'm seeing that it seems to be doing a really great job of not altering aspects of the signal where we don't see motion, and it also seems to be doing a pretty good job of grabbing these areas where there is motion and correcting for that. Yeah, overall, this is looking like a pretty good fit for at least this person. I usually, um, go through more than one subject to make any conclusions about what's best for the data set. But just for the sake of time, we're going to move on to some other things. One more thing that I will mention that we do in our own research is we do not always apply motion correction to every subject. So I showed you here this person did have certainly some prominent motion artifacts in their signal. If you have participants who are not showing motion artifacts, you may prefer to not apply any algorithms to them because you don't really have any interest in altering your signals. So you might sometimes consider taking a subject by subject approach. I will say that NIRS KIT does not let you take a channel by channel approach. So whatever you do has to be applied for every channel for that subject. This is kind of what I mentioned too with having separate folders here. So usually if I'm planning to pre-process different people in different ways, I sort those files into separate folders so that when I go to pre-process the data, it's very clear to me what subjects need which steps. So in my own research, I start to sort this data prepared file into this other file where I select subjects that do have motion artifacts and I would like to apply some correction to them. And then I also have some subjects here who I did not identify motion artifacts for. So I've named my file no motion artifacts. When I go to pre-process the data, it's going to be very clear to me that, for these people, I can skip this step. As I mentioned, another very common and important part of working with fNIRS data is to filter the data. So NIRS kit gives you three different methods, IIR, FIR, and FFT. If you are curious about what these mean, I would recommend doing some literature searches. And then also NIRS kit has a really wonderful user manual. So that's always a great resource if you're not sure how to do something or what a specific thing might actually do to your data set. I would definitely recommend looking at that. Most commonly, what people are interested in filtering out from their fNIRS data is like I mentioned, the heart rate influence, and then also any other physiological influences like respiration. One of the most common ranges I've seen for a filter, so most people do a bandpass filter in NIRS kit, that's filter type 3. The default order is 3. We can leave that for now. And then I usually tend to see people using a range of 0.01 to 0.2. And then I can apply that. I obviously removed the motion correction step, so I can apply that and I can now start taking a look at how my data might look if I filter it using this filter. Just toggle through. You can make your own judgments about whether or not you think it's an appropriate fit based on what you plan with doing with the data after you use it. I'm going to make a video after this kind of explaining how to do post-processing in NIRS kit. So I'll quickly mention now that if you're going to follow my exact methodology, what you should do here is plan to apply motion correction to the subjects that need it. And then actually for what I'm going to show in another video for that specific experiment. I did actually a IIR low pass filter order one, and my cutoff was zero point 0.1 hertz. So if you were going to do that, you could do a quick visualization of that using the data and follow along with how I pre and post process my own data set. But like I said, totally up to you and what the literature is suggesting and what makes the most sense for your data. So let's just say that you had done all of this, you've explored the data, you've gone through person by person, excluded all the subjects that you need, and you're actually ready to apply some of these algorithms to your data set. So what you can do is just close out of this window. If you close it, it's going to save all of the channels that you excluded. So you don't need to save anything. Just press the X. And then what you'll do is click this pre-processing segment. You'll add your data path. So I, in this scenario, have sorted my data into people with motion artifacts and people with no motion artifacts. So first I'm going to select my folder that has people with motion artifacts. You can see all my subjects are here. I'm going to select my output folder to be my pre-processed data folder. And then I'm going to add the things I want. So the motion correction should come before the filtering. That's pretty standard. Like I mentioned, I use TDDR, and these are my people with motion artifacts. So then I'm going to add my filter. As I briefly mentioned, for this one specific application, I decided to use a low pass filter, order one, with a cutoff of 0.1 hertz. Once you have all of that done, you just click run and it will run and save all your data. And then if you were doing it the same way as me, once you had run it, you would go to your other folder, people who don't have motion artifacts. You would remove the motion correction step and only include the filtering step. I have to re-input these parameters again. Low pass, order one, 0.1 hertz, and then you run it. If you're interested in taking a look at all of your data that's been pre-processed, you can still use the visualizer to do that. Um, so here's my pre-processed data folder. I can select this, and now I can go through. You'll notice that, these people, their channels are still shown as excluded. And as I'm flipping through, the data looks, quite a bit different now, because it's been pre-processed. So you can go back through here if you want to look at what happened. But if not, your data is ready to work with. So I like to do a lot of analysis using NIRS KIT, but if you have your own analysis that you're interested in doing that is not a function that's automatically built into NIRS KIT, then you can go to your pre-processed data folder, click on your subjects, and all of these files can actually be opened just in MATLAB. So here we have this struct that I just loaded. It's called NIRS data. If I click into it, I'm going to see some different fields. So our oxygenated hemoglobin data, which is more than likely what you're going to be working with, is going to be stored here. So I have a 22 channel system. We can see our 22 columns. The excluded channels are now filled with nans. And then our rows correspond to our reading at that sample. So we have a 50 hertz sampling rate. We've got a lot of data here. We could, in theory, use MATLAB to do whatever we want with this oxygenated hemoglobin data. We also have this NIRS exception channel. So any cell that contains a 1 is going to be, we flagged that channel to be excluded. If you're doing your own analysis, you should, make sure that you're paying attention to this specific field and excluding the data. so that you're not accidentally considering the results of a bad channel. And then, yeah, you can mess around with this if there's any other parameters that you're curious to explore. Some people do like to work with deoxygenated hemoglobin and total hemoglobin. I personally don't do that, but you have those outcomes here as well. And then the other thing that I'll quickly show is these multiple conditions files, which are super helpful to work with. So I'm going to open this in MATLAB as well. So if you're like me and you do task-based data recordings, you've likely, flagged in your data where some events are starting. So what we can see here, first of all, is the names of the tasks that are happening in your data recording. For me, that's a dual task and a rest. And then we have this onsets field, and that's going to tell us which index those events start at. Um, So for this specific person, they have the rest is their first task. It starts right away. And then uh, around the 12,000th sample, there's a new event starting, the dual task. So we can use these two indices to also, take into consideration in whatever we're doing with our data. And that pretty much sums up how to do the pre-processing in NIRS KIT. I'll have some additional videos on how to do post-processing in NIRS KIT. But yeah, like I mentioned, the user manual is a really, really fantastic tool. I highly recommend that everybody refer to it for any questions, complications, or just better descriptions of what's actually happening with the data in NIRS KIT.